Everyone, this is Sakshata back again with another exciting video. How are you guys? Namaste to you all. And in this video, guys, we are going to learn how to count set bits in a given integer. And for excitement, I want to tell you that this is a question asked in Adobe, Cisco, and many other companies. So, guys, let's see how we are going to tackle this question. Okay, so what is the question is the input is provided, and what you have to do? First of all, it is to be converted in its binary, and you have to calculate all the set bits, means all the number of ones in that particular integer. So let's see what how we are going to approach. The most effective approach is that we are going to maintain a map. Map means a list, array, you can say that. Two bits of for a nibble. Nibble is just a like of a set of bits, small set of bits from a large bits. What we are maintaining, we are taking a four sets, means 4-bit sets, which is from 0 to 15. What I'm going to do is just maintain an array which contains the count of set bits from the number 0 to 15. Okay, which will act as our map. Okay. So what it will do it that on every 4 bits, what we are actually doing is if a number of 16 bits is given, then we divide it into 444. For first last 4 bits, we will count that are there, then for next, then next, and then next. So what it enhances is us that the time complexity becomes constant as well as space complexity. Now many of you must be thinking that we are using a space, but friends, this is a constant space, means it's not dynamic, not increasing or depends on any number integer value. It remains constant whatever may the value of the given integer. Okay. So now without wasting time, let me move towards my code editor and let's write the code. Okay, so over here this is the number 2 bits, means from 0 to 15 it contains all the set bits count. Okay, now what I'm going to do is, first of all, I'm going to say my last bits, means that 4 bits which I'm going to take initially should be 0. And now what I'm going to use recursion in this. Okay, so in recursion, the first and foremost rule is the base case. So the base case will be, guys, that if my number becomes 0, then what I have to return is, means that has the set bits of 0. So what I will say, num to bits of 0. Okay. Now in other cases, I have to calculate my last bits. Now my last bits will be what? That number, and it will be bitwise and with 15. Why 15? Because 15 contains 4 ones. Okay, so it will provide us exactly what that last bits contain. I hope you are getting this point. Yeah, fine. So now what I am going to do is I am going to now say return num2 bits of what? My last bits. Now plus I have to keep on updating it. Now what my next number will be? 4 bits I have counted, that for the last 4 bits what was the sum of set bits. Now for next what I will do? I will say shift by 4 bits. This is a bitwise shift operator which I am going to use. Okay, now let me quickly check for, suppose 31 we are taking itself. So I am saying print count set bits of number. So 5, yeah, as we have seen over there. So what is happening over here? It, first of all, we are saying for that particular number, when it calls, that the last bits is 0. Okay, we don't know what there it is. Now if number is not 0, then we will update our last bit, means that number and 15. It will give us that last 4 bits of that particular number. How it's going to give is, because if all other bits except the last 4 bits, I want 1 1, else will be 0, and anything multiplied by 0 is 0. Okay, I hope you are getting this point. And what I will say that my two bits of last bits means this is the sum of that 4 bits which I am getting from here, and then call next further 4 bits. To give you a more clear vision, I can say let's see a dry run. Say this is our all the array which contains the sum of the set bits. Now what is this? Initially my number is 31. So what I will do is that to calculate last 4 bits of that number, I am going to AND it with 15, which means with 4 ones. So what it does, see, all else will be 0. So whatever is coming after except these 4 bits will be 0. That's why we are bitwise and with 15. So I am getting itself 15. So means my last bits will be what? 15. So now it will go to num2 bits to this array and say give me the sum of 15, which is at index over here. So it will give me 4. Okay, and now my answer contains 4 and it will call count set bits, means now it has to increment that, update it. Now my number will become what? My all the other are shifted and my number contains now 1. So now I will say count set bits and I will call with 1 like this. Now my number will be 1 and see what it contains. I will again now check for this particular what is the last bits for it. Number 1. So what I will do is that with my number 1 I am going to AND. Okay. Okay guys, over here is a bit mistake that I have to just do it, that 1 will not come over here. No matter over here a 0 should be coming, so please excuse me for that. And my now last bits will be what? 1. So for the index of 1, what is the set bits? 1. So now my answer will contain 1 in it. Now it will update my number, which is now what? 0. It will call count set bit 0. Now it will turn what? 0. So now this 1 and this 4 will add on, and what I am getting is 5 as my answer. Okay, I hope you got this solution, and it's a very fruitful method. Now we are in the Python, so there must be another method. Yes, there is, of course, and there is no denial in that. So just a one line code, what we can do, bin, it is for binary, to convert any number into binary. So what I will say, suppose I have a number 31 and I will use a method count. What? I have to count all the set bits. So I will say do this, and as simple as that. Yeah. Are you liking the power that Python provides us? I am also liking that. So guys, that's all for today's video. I hope you liked it. Please like, share and subscribe for more such videos by my side. Till then, keep coding and see you later. Bye bye.